For thousands of years, food did not survive because it was frozen, sealed in plastic, or pumped full of preservatives. It survived because people learned how to let the right organisms take control before the wrong ones could. Long before refrigeration, entire societies depended on a subtle but powerful method that modern people often misunderstand: controlled fungal preservation. This was not decay. It was not desperation. It was a deliberate system refined through generations of trial, failure, and survival. Families pass down starter cultures like inheritance. Lose the culture, and you risk losing the winter. Keep it alive, and you could feed children long after harvest season ended. This method defied spoilage not by slowing it down, but by replacing it with something stable. Spoilage happens when uncontrolled bacteria and molds consume food faster than humans can use it. Ancient people saw this clearly, even without scientific language. They noticed that some foods collapsed into slime, while others hardened, dried, or transformed into something entirely new, yet safe. The difference was timing and control. When certain fungi colonized food early, they altered the environment so thoroughly that harmful organisms could not survive. Acidity increased, oxygen disappeared, and natural antimicrobial compounds formed. Once this happened, the food stopped changing rapidly. It entered a preserved state. This was not luck. It was repeatable, and cultures that mastered it thrived. Protective fungi grow fast and spread evenly. They form networks that regulate moisture and consume available sugars before bacteria can use them. This biological dominance is what made fungal preservation reliable. European cheesemakers encouraged specific surface molds that sealed food from the outside. Asian grain fermenters relied on molds that penetrated deeply, transforming food from within. African cereal cultures allowed wild fungal and yeast communities to stabilize porridge into long-lasting pastes. The common thread was ecological control. Once the fungus won, rot lost. In East Asia, molds such as Aspergillus oryzae became essential to survival. Cooked rice or barley was cooled, inoculated with active culture, and kept warm for a short period. During this time, the fungus produced enzymes that broke starch into sugars and proteins into amino acids. This not only preserved the grain, but made it easier to digest and store. From this base came miso-like pastes, sauces, and fermented staples that lasted months in cool storage. Even today, this method can be applied by fermenting grains into dense pastes stored in ceramic or glass containers in cellars or shaded rooms. In Europe, fungal preservation allowed meat to survive long winters without heavy salting. Lightly salted cuts were hung in cellars where airflow and humidity favored protective molds. These molds slowed moisture loss, prevented surface rot, and produced antibacterial compounds. Over time, the meat dried evenly rather than spoiling. This method required observation rather than equipment. If the mold smelled clean and grew evenly, the meat was safe. If it turned slimy or patchy, it was discarded. Modern practitioners can still apply this technique using controlled environments and known cultures, reducing reliance on refrigeration. In Southeast Asia, rhizopus mold turned soybeans into tempeh, a food that resists spoilage and improves nutrition. The fungus binds beans together, creating a solid structure that limits oxygen exposure. The process involved soaking beans, cooking them, cooling them, and introducing starter culture before holding them at warm temperatures. Once the fungal network formed, the food stabilized. Dried or lightly fermented tempeh stored far longer than cooked beans and provided reliable protein during scarcity. This remains one of the most practical fungal preservation methods for modern off-grid living. Ancient people did not need to understand microbes to understand outcomes. Food preserved with the right fungus lasted longer, caused fewer illnesses, and tasted better over time. That was enough. The method worked because it relied on ecological balance rather than constant intervention. Once established, the fungal system maintained itself. This is why it survived across cultures and centuries. Modern food systems depend heavily on energy. When that energy disappears, alternatives are rare. Fungal preservation offers resilience. It reduces dependence on refrigeration, improves nutritional density, and creates food that stores safely with minimal resources. This is not about returning to the past. It is about recovering tools that still work. If this exploration added real value to your understanding of how ancient knowledge shaped human survival, subscribe to Past to Live, share this with fellow history and resilience enthusiasts, and help keep these forgotten skills alive. The past still holds answers, and some of them are growing quietly, just as they always have.